of IIT Academy. In this video, I am going to explain about the coordinate geometry. Since it is a first video, let us see the basics in coordinate geometry. So first of all, let me explain about the coordinate axis. So what is meant by coordinate axis means the position of a point with reference to two intersecting straight lines in a plane is determined is called coordinate axis. Okay, so suppose here this is a plane and here now this is a point I am taking P. Okay, to find the position of this we need two straight lines here, and when they are intersecting here then we can find the position of the point P. So here these straight lines are called the coordinate axis, and usually we take as x dash and here y dash. Okay, so when these coordinate axes are intersecting at 90 degrees, then coordinate axes are called rectangular axis. Okay, so here it is x dash and here y dash. Okay, so right side of the x axis will take positive values, and above the x axis means along the y axis will take positive values, and here will take negative values, and here positive values, and here negative and also negative, and here positive and negative. Okay, so it is very clear that in a plane when two straight lines are intersecting, the total plane is divided into four parts. Each part is called the quadrant, and this is called the first quadrant, and second quadrant, and third, and this is fourth. Okay, so now we will see how to find the position of the point. So here I am taking the OX and OY axis. Okay, now I am selecting a point P here. Now what I am doing is here I am drawing perpendicular, so let it be some Q. Now the perpendicular distance from the point P to the x axis, that means your PQ length is suppose y, and here OQ is equal to x, then we can write P x comma y. Okay, so always you have to write point in the order pattern, so in which first coordinate represent the x value means x coordinate, and second coordinate represent the y coordinate. Okay, so here what is meant by x and also y means here when you see this is also perpendicular, OQ is perpendicular on OY, and also this PQ is perpendicular on OX. That means here x means perpendicular distance from the y axis is called x coordinate, or the value of x here, and here what is meant by y means here perpendicular distance from the x axis. Okay, so now here this x coordinate is also called as abscissa, and here y coordinate is called ordinate. Okay, so now here the point P x comma y, this is the position of the point P. So this is a point in not only the first quadrant, we can take in any quadrant. So sign also will be changed based on the quadrant or the position of the point. Now when you are taking a point which is on the x axis, here the distance from the x axis to itself is 0. So that means here y coordinate is 0. So here x coordinate is x, you will take, and comma 0. That means point on x axis is what, x comma 0, and here point on y axis means here there is no perpendicular distance from the y axis to itself, means 0. So that means here 0 comma y. So here point on y axis is equals to what means here 0 comma y. That means here on y axis abscissa is 0, on x axis ordinate is 0. So abscissa and ordinate is 0 at the origin. Okay, so this is about the basic things in coordinate axis. Okay, so now we will see polar coordinates. Okay, so polar coordinates. So here I am taking a ray, suppose OX and O is a fixed vertex or the vertex indeed. Now when you are rotating this ray along the fixed vertex up to some point, suppose P. Okay, so now the distance OP you can take it as suppose R, and when you rotate this along the anti-clockwise direction, angle will be formed. So this angle is the clockwise direction, so anti-clockwise direction, so that it is positive angle. So here when you are shifting this along the clockwise direction, angle becomes negative, so minus theta here. Now here the point P can be represented as r comma theta, and here this is also r comma minus theta. Okay, so here P of r comma theta is called polar coordinates. Okay, so now we will see the relationship between polar coordinates and Cartesian coordinates. Okay, so now here I am taking a point P. Okay, so now join OP and also draw the perpendicular distance. Suppose here, suppose M you can take. Now here you can take the angle theta, and OP is equal to suppose R, and point P we are taking as suppose x comma y. That means here PM is equal to y and OM is equal to x. Now we are going to get the relationship between the coordinate axis, coordinate plane means Cartesian coordinates and also polar coordinates. So now here in this triangle OMP, when you apply cos theta, so cos theta means here adjacent by hypotenuse, so here x is equal to what? R cos theta. And the same triangle when you apply sin theta here, sin theta is equal to opposite by hypotenuse, so hence here y is equal to R sin theta. Okay, so now x comma y we can write as what? Here P of R cos theta comma R sin theta. So this is the point in polar coordinates. So now see here, when you are taking square on both sides, then here you will get x square is equal to R square cos square theta, and here also when you are taking square on both sides, you will get y square is equal to R square sin square theta. So now add these two, then you will get here x square plus y square is equal to R square into sin square theta plus R square into cos square theta. So when you are taking R square common, then you will get sin square theta plus cos square theta, that value is equal to 1. So hence it is y square plus x square is equal to R square. And when you are dividing here y by x when you are dividing, then you will get here R sin theta by R cos theta. So hence R will get cancelled, and sin theta by cos theta is equal to tan theta, and tan theta is equal to y by x. So here theta is equal to tan inverse y by x. Okay, so the angle actually which is based on the position of the point. Okay, so that means if the point P is in first quadrant, it has a different angle. So here the angle theta is based on the position of the point in which quadrant it lies. Okay, so here we will, when we are taking here alpha is equal to tan inverse of here y by x, then in the first quadrant we will see here all the quadrant. So here the first quadrant there is no change, so here both the x and also y coordinates are positive, so here we can take alpha. So next here in the second quadrant we have to take primary as alpha, and next minus pi plus alpha, and here minus alpha. Okay, so these are the angles which are in the different quadrants. Okay, so this is about the relationship between the polar coordinates and also Cartesian coordinates. Okay, so that's all about the video. Thank you for watching. Thank you.